So I'm here to tell you and take you on a little journey on how we onboard customer networks. What I hope to do is to inspire at least some of you, give you some ideas on methods and theories that you might use in your own environment in the way we do things. Some of you may be way ahead of us. Some of you may be lagging, and I'm hoping to inspire the people that are behind us with some of the ideas. So this is me. I'm Frans ter Borg. I'm the founder. I started Quanza almost 25 years ago, and we've grown into a company of 85 people now. We manage mission-critical network environments that are societally relevant, and some examples are on the screen. We manage the network for the Port of Rotterdam with all of the radar stations. We manage the network for SURF 24/7, which connects all the universities and other educational institutions in the Netherlands, academic hospitals, the Municipal Transport Authority of Amsterdam. We're the 24/7 NOC for the M6, and we are currently onboarding the network for our public roads and transport authority, Rijkswaterstaat. What I'll be showing you is the 4 steps that we go through when onboarding a network. The first step is to make an inventory. One of the things is that most of the networks that we manage are relatively large. There are hundreds or thousands of elements. And it is crucial for scaling to make sure that we do things in a somewhat standardized way. Not every network is different, especially because we enter in a brownfield environment, in an environment that is already there, in which we haven't made the choices for the design. But we want to be able to bring it back to something that is manageable. We need to make sure that our colleagues recognize certain building blocks, that we can do the support in certain discrete blocks, even though the underlying infrastructure might be different. It helps in onboarding new employees and explaining things also to the customers. So standardization always benefits customers as well. So the first step is to inventorize, and we do this in 2 streams, if you wish. There's a technical stream, and there's a less technical stream. I'll start with the less technical stream. In the less technical stream, we inventorize what software is in use. How up-to-date is this software? What has the vendor told us about this software? Is it end of development? Is it end of bug fix? Are there any vulnerabilities in that software that require us to upgrade it because we are running major risks? It's stuff that we want to know before we take over the actual responsibility. If there are CVS scores higher than 8 or 7, whatever we discuss with that particular customer, we want to know, and we want to have some time at the beginning of the contract to make sure that the network comes up to that standard. If we manage an environment, we want to know whether all of the assets are covered by vendor support. The contracts should be in place. What's the start date? What's the end date? What can we expect of the vendor? Is there equipment that cannot be covered anymore because it's too old? It's been end of support. It's been end of sale, end of supported. We want to know to identify potential risks for us and for the customer, and to identify potential projects to mitigate those risks. And nowadays, more and more network hardware vendors use software subscriptions to open up certain functionalities on routers or switches or firewalls, and we need to know the same thing there as well. What is covered? What sort of functionalities do we have? Where? Then how do we need to? When do we need to renew those subscriptions in order to keep the network up and running? We register everything in databases so that we can manage that process. Then we have a technical track. clearly we need to know about what is in the field. We automate device discovery. What is the type of device that we find in the field? Router brand, type. What are the types of modules that are installed? What kind of optics are installed? Everything is registered. Also, the links between the devices. For example, the IP configuration on one side, and if we find the other device, we can make the match. We know what device is connected to the other one. We can use CDP, LLDP type checks to make sure that what we think should be there, that the devices recognize each other. What sort of a port is it? Is it a backbone link? Is it a link to another provider's network? Is it a link to a customer? What is the type of service that is running on that port? What has been sold to the customer? Sometimes we know, or the customer that we are working for thinks they know what they have configured. So we use their input and validate. And if they don't have the input, we try and recreate it. One thing that is also very important is to know about the physical network. Where are the cables in the ground? What type of cable? Where are the handholds? We want to understand what is between certain devices if they're in different locations, so that we can use that information to do impact analysis in case of an incident or in case of a change that we are planning. So we want to know who to inform when either an incident has happened or when we are planning a change. The second step after inventorizing is to standardize the network. We find many different things. And this is an example. For some of you, it might be rather technical. It's an interface configuration on the left and on the right. Functionally, they would do the same, but they are slightly different. Some of the statements are just slightly different. And in order to be able to take this network in our management, we want to make sure that this is standardized. Some redundant statements might be removed or added, depending on what we find. But once everything is the same in that network, it makes it much easier to come to a certain automation, and we'll get to that in a little while. This can be quite a lot of work in large networks. The third step is to normalize, and this is, again, leading up to automation. So looking at the same standardized configuration, there are certain elements that you can recognize within that interface configuration. There's a port configuration about physical characteristics. Are we doing auto-negotiation? What are the settings for the optic, speed, and stuff like that? The layer 3 configuration, IPv4, IPv6 addresses, we want to recognize that as a certain block. Maybe the port is running multicast. If so, then that is a block that we want to recognize. And the same for MPLS. And there might be other configuration items. We want to group those to make it easier to put it in a database and use the information at a later stage. The database is our single source of truth. It's important to have a single place for every type of information. We try to put as much as possible in one database, but you might have various databases as long as there is only one source, one database of truth for each type of information, so that you know where to go at a later point. And then on top of the source of truth for network infrastructure components, you also need some form of registration for your services that are running on top of those of the infrastructure. So this is the normalizing stage again. We use a method that is defined in RFC 9408, a Yang model for service modeling based on a service attachment point, where you can see that a port on the left, a core port might have an L3 configuration that we've normalized in the previous step, an MPLS configuration, OSPF configuration, and a multicast configuration. And then there is a user port on the right, which might be connected to the same service, where you essentially offer the service to the customer, which might only have a layer 2 configuration and a layer 3 configuration, for example. So you sort of model how this particular service, what sort of configurations would be needed in the network, and you use the database information later on to push that information to the customer network. Then what we use the single source of truth for as well is to make sure that we have a universal, integral, and a consistent view everywhere where we use the information. So, for example, we use Zabbix for monitoring. We'll get to that in a bit. We push the information from the CMDB, from the single source of truth to Zabbix, so that we always know that we are looking at everything. As long as it's in the database, it's monitored. We do configuration backups of the network devices. We provision DNS. In our case, we use Power DNS. We use a tool called null to do troubleshooting, and we use Vault for password management. A device, a particular type of device, can be in your network with a variety of roles. And it's, for example, a Juniper MX or a Cisco ASR. It could be in the network in the core as a P router or as a PE router. It might have a role in a customer environment. It could be a BRAS, for example, or it could be a peering router. So the hardware could be the same, and we use a sort of layered template approach in Zabbix, where we say, okay, this type of hardware, we always want to monitor certain physical characteristics of that hardware. But depending on the role, we will add templates which will monitor in peering, BGP state in the case of peering, or subscriber characteristics in the case of a BRAS. So we can sort of, based on the role that we have defined in the single source of truth, push the right configuration templates to Zabbix so that we know what we want to know. And if we ever need more information about a peering router, we change the template, and it will be applied to all peering routers. So it's always consistent. Yeah, essentially we don't do anything manual in Zabbix, and that makes our lives easy. Once it's implemented. Beforehand, it's quite a lot of work. So then we make configuration backups. We use Oxidize for that. We push the configuration, or essentially Oxidize retrieves the information from the CMDB, and using Vault, we can log into all devices and make sure that we have a time-stamped version of the software of the configuration that's running on the box. If there is ever an issue that the customer reports, we can always sort of go back to the point in time where the customer started noticing these problems, see what has changed, if anything has changed, and yeah, in our analysis, find out whether it's a configuration issue or whether there might be something else wrong, a physical issue somehow. DNS, as I said, we use Power DNS. We can push a record for the host name into the DNS, whether it's public DNS. In a particular customer environment, it might be a private DNS server within their network. Sometimes we might use public DNS servers, depending on the customer environment, really. But we don't need to touch that server. It's all done automatically. Yeah, as I said, null. Our friends from NLIX many years ago had this tool, and we've used the IDE and tried to improve it for ourselves, allowing us to log into devices a bit more easy instead of typing in very long router names or IP addresses and long customer domain names. We just, as I say, or we just connect to some router name, which makes it easy and quick to do analysis. Then stage 4, the automation stage. There's a variety of tools that we might use. There are many more available, but this is just our menu options, essentially. Depending on customer budget, complexity of the network, on the SLAs that the network might have with its customers, we use Ansible. If you make that really big, it might become a bit unreliable. Recently, we've started using Nornir in larger environments. It works really well. It's highly customizable, but it's very it has a very steep learning curve, so it's not something for junior engineers. You can do a lot and build a lot yourself with Python, but again, this is something for the seniors generally. It's extremely fast. It can do a lot in parallel. 10,000s of devices can be read in minutes, where in the past it might have taken hours. And a very powerful but also very expensive tool is Cisco NSO. Cisco NSO is Cisco's network service orchestrator. It's an acquisition by Cisco. It was a company called Telef, and yeah, it's very strong. It can do a lot of consistency checks. It has rollback functionalities. It allows you to model services on top of an infrastructure in a very concise way. So it works really well, but it's expensive and not for every budget. One thing to keep in mind with automation is once you want to introduce a new product, what is the information that you want to capture about that product that allows you to put it into your database and keep the same consistency. So what sort of information do you want to capture about a location? For example, some carriers might need a zip code and a house number in order to identify a location. But in the networks that we are currently managing, not every location actually has a zip code. So we need to work with GPS coordinates and some instructions about where in a building or in some outside environment is the infrastructure located, where is the box that contains this router. So you need to think about this when designing new products, because if you forget, then things can get very messy very quickly. Yeah, for documentation, we use a wiki, and in the past we used to have essentially multiple versions of the truth, which makes everybody's life miserable. We're moving into a wiki that can include information from our CMDB. We can include tables. We can include images. We can render network diagrams in our documentation system from that single source of truth, so that everybody is looking at the same version of the truth. Again, if you have something in a wiki that's been statically or manually put in there, something has changed in reality. It makes it very difficult to talk between departments, to talk with the customer about that same truth. So we're really putting as much effort as we can into integrating these environments and make sure that we talk about the same thing. It makes things more predictable. It makes it easier to troubleshoot and to discuss things with the customer. Another thing that the CMDB or the single source of truth allows us to do is to send rich alerts to our NOC. Subex might send an alert saying, hey, this router is down. And that used to be the first step for our NOC operators to start working on an incident and to do an assessment. It's like, hey, what customer is this router from? He would look in a database. What is the physical location of this router? What are the services that are running on top of this router? What location is this router in? If we wanted to access it, are there any particular access instructions? Do we need to call someone to come to a site with a key? Is the device still covered by a vendor support contract? So what we do now, instead of sending that message from the monitoring system to our ticket system, saying, hey, this router is down, we use a message bus, which adds information, all of the information that I've just mentioned, and depending on the type of device and the type of network, we can be flexible, so that once the ticket arrives in the monitoring system, our colleagues at the NOC don't have to click open 15 different systems before they start troubleshooting. They have all the information in one screen, and they know where to go from there. So it allows us to do much quicker analysis than we used to be able to do. Another thing I mentioned before, and we're getting to the end of my presentation, so I've hopefully helped you make up for some time, is to store cable information. A circuit underground. At the top, you see a router with an interface with a patch cable connected to it. It goes to an ODF, to another ODF, and then it connects to a dark fiber between two locations. All of this information is stored in our single source of truth, and these types of images are actually rendered within the CMDB and can be presented in a variety of different ways. Depending on the need for detail, we can integrate with tools like Cocon, which a lot of our customers use. Cocon is a very frequently used database with cable information, underground cable information, essentially. What are the coordinates for a cable? What are the coordinates for the handholds? How many tubes are in a duct? What fiber within a tube is being used? So those types of integrations we can now make. Again, this allows us to do impact analysis on a very, very deep level. If we get a carrier or a change that we initiate ourselves, saying, hey, we're going to do work on this fiber, we can go up and down for impact analysis and say, hey, what services are running on this, or what customers are using this service, and it allows us to work efficiently and in a very good way. Essentially, that was everything I had to say. I hope that some of you may have been inspired a little bit by how you can approach using a single source of truth to manage your network. Some of you may be ahead, I don't know. If you have any questions, let me know.
It sounded very much like you have a question for everyone here. Like, is there anyone who feels like their companies or their organizations are further ahead with the single source of truth model that Frans was talking about? No? No one here? And do you have any questions for Frans? No? Everyone's shy? Or
I'll
you
be
want
available
to speak to
for a while during lunch as well, if you want to discuss things more privately.
One thing that, I mean, I, from a very much an outsider's point of view, picked up on was, I can understand the benefits of normalization and standardization, but I mean, it's such a colossal amount of work involved in doing that. What are the challenges in automating that, like the network onboarding, for instance?
We use a lot of automation tools, and we develop them ourselves in order to do the normalization. What we generally find is that customers have used a certain approach, but it's not always been used to the standardized to the fullest extent. So we try to recognize patterns, like the normalization or the standardization that I showed you with minor changes. We try to discover these minor things, like what is the duplex setting, what's the speed setting. Those are not so important, so it's easy to filter those out and make sure that we replicate those to the other side.
But will there also be customers who don't meet your standards, and so you kind of have to say, did you help them upgrade, as it were, or do you say, come back when you're ready?
No. We can always help them get to that stage.
Yeah.
But the onboarding might take a little longer.
Yeah.
And this can be months. So it's definitely not something that can be done, well, depending on the size of the network, of course. But generally, these are months-long projects.
Okay, great. Thank you very much.